Very morning very much my fellow brain-dead rabbits. Some days ago I unsuccessfully explained the concept of ray tracing, and as I see, you still want to learn further. Seems like you recovered from the trauma my first video caused you. Alright then, prepare your rectum. To start, you might be asking, where does rasterization comes from? Sorry, I am not going to explain it by. I'm going to explain my method of rasterizing. There are surely faster and less stupid methods. But my brain has an imaginary number of brain cells, so I'll just tell you the thing I made to draw two dumb triangles on a console. To start, we create a structure that will be the input parameters. For example, this one. Sadly, I have no clue how to get the normals of different triangles without drawing the vertices before. So for now these will appear sharp. To make things less complicated, we use structures of float or fixed variables that contain color or vector data. By the way, I am explaining it as a C++ method. I don't know how some other programming languages work. Okay, so as I was saying, this structure contains the data from their mesh, not all of it, just the basic data. The position is, as its name says, the position the vertices are at, from the center of the object or pivot. If you are wondering about the w-axis, it is a value that divides the position depending on the camera distance and field of view. For perspective purposes, the normal, as I explained on my previous video, is the direction a vertex is facing at. And this little fella right here, is the position on the texture that the vertices will have. This structure will go through a program that will convert the input vertex data into another structure. This program is called Vertex Program, and it exists to specify the screen position of the vertices before being drawn on the buffer, and also to calculate data that doesn't need to be calculated for each pixel. Since I was supposed to explain how to rasterize, I won't go further than that. Now the next program is where stuff happens. It's called Pixel or Fragment Program. Here the pixels are drawn on the buffer and output on the screen. The buffer is the reserved memory on the program that contains temporary data. In this case it's a matrix of as many colors as pixels are on the screen. Okay, let's start. To rasterize a triangle, first you have to order its vertices from first to raster to last. My method creates a new vertex next to the middle one and between the upper and lower ones to divide it into two triangles. That way you can just draw a line that increases or decreases its scale from 0 to the distance between the middle vertices. First, to order them, compare its Y position. This will be a lot of branching. Apologies in advance for being dumb. Now to get the extra vertex, we need to use a function that interpolates all vertex data linearly, better called lerp. To get this vertex, A will be the upper vertex and B will be the lower one. Now, what about the factor? For that we will make another function that converts the upper and lower position into a range from 0 to 1. So it would be like this. Now with an ordered triangle, we can start the main rasterization process. For that, we have to get the first triangle's length in pixels. For example, 32. We will also get the length between the middle and additional vertex. For example, 13 pixels. We will also need the x and y offset in which the triangle will be drawn at. For example, 24 and 16. Another offset we need is the one that varies from the length between the right middle vertex and the upper one to 0. For example, 20. Now the last data we will need is which middle vertex is closer and which one further from the x-axis. For that we create two new vertex data constants that will also be reused on the next draw, and order them depending on the middle vertex's x position. So now we can start drawing the first half. We make a for loop that will be the horizontal lines. Each iteration will be a line, so we will use the triangle length to iterate. Inside of the loop, we'll create a variable that represents the process of the loop, where 0 is the start of the loop and 1 the end. Now since this is the first half, We know that the line length starts at 0 and vice versa for the line offset, so we just need to create two variables as shown below. Now we also need to get two new vertices that interpolate depending on the process of the loop. For that we will loop again between the upper vertex and the middle ones. Now, to draw the line, you have to make another for loop. Its length will be the line length variable we made up here. We'll create another process variable for this loop to get the line position. And then with the two vertices we created before, we'll get the one in between them according to the process. Now with that data, you can execute the fragment shader. That's right, in difference of the Vertex program, this one executes the program for each pixel that the polygons cover on the screen. I guess it's obvious, right? Though the fragment shader is something I want to explain on the actual tutorial, so we'll skip it as my person as colors, because I can and I want. And, before drawing the pixel, we have to specify which position will it have. That's simple. The X position will be the one above plus the line offset plus the X iteration, and the Y will also be the one above plus the Y iterations. Now you can finally draw the pixel on the buffer. If you want, do it directly onto the screen. By the way, this function does not exist. You can use the setPixel function for the console, but it's obviously not how it should be done. If you really want to write a rasterizer for real-time graphics, this would be the complete function on the first half. Do not fear, to do the second half you can do the function again, but inverting the process on the line length and offset, and the interpolations will range from middle to lower vertices. Finally, we output the buffer on the screen and we get to see the beauty of this triangle. Now that this mess is over, I can finally start explaining what I want to explain. On the next video we'll start with the basics of shading and I will go further with each video. For now, go play some VR chat and give some love to your favorite Nanachi.